There are places in the universe where the rules we rely on begin to break down. Regions so extreme that our everyday understanding of space, time, and matter no longer applies. In these environments, gravity doesn't just pull, it overwhelms. Time slows, distance warps, and even light can be trapped. At the center of many galaxies, including our own, lies one of these regions, a supermassive black hole. For a long time, black holes were thought of as cosmic destroyers, objects that consume everything around them and leave nothing behind. They were imagined as endpoints, places where matter simply disappeared. But as our ability to observe the universe improved, that idea began to fall apart. Black holes don't simply erase matter, they shape galaxies. When astronomers began studying the motion of stars near galactic centers, they noticed something unexpected. Stars weren't orbiting empty space. They were circling something incredibly massive, packed into an impossibly small region. In our galaxy, that object is Sagittarius A. It contains the mass of millions of suns compressed into space smaller than our solar system. Despite this immense gravity, the black hole itself is often surprisingly quiet. It isn't constantly feeding. It isn't constantly erupting. Instead, it waits, influencing its surroundings through sheer presence. This calm is not weakness. It is control. The gravity of a supermassive black hole helps regulate how gas moves within a galaxy. When too much material begins to gather, the black hole can become active, releasing enormous amounts of energy back into its environment. These releases don't always look dramatic. Sometimes they unfold slowly, over thousands or millions of years, but their effects are profound. Energy from the black hole can heat surrounding gas, making it harder for new stars to form. In some cases, powerful outflows can push gas outward across vast distances, reshaping the structure of the entire galaxy. In this way, black holes act less like cosmic vacuums and more like regulators. They help determine when galaxies grow and when they pause. This brings us to something easy to overlook. Galaxies need balance. If stars form too quickly, a galaxy can burn through its fuel early and fade. If star formation slows too much, growth can stall entirely. Supermassive black holes help prevent both extremes. By limiting growth at critical moments, they allow galaxies to evolve more gradually, over billions of years, rather than in short, violent bursts. And this influence is not limited to one galaxy. Across the universe, nearly every large galaxy appears to host a central black hole. Even the earliest galaxies we can observe seem to have formed alongside them. Their masses closely track the size and structure of the galaxies they inhabit, suggesting a deep and ongoing relationship. It's as if galaxies and black holes evolved together. Still, many questions remain. How did these black holes form so early in the universe? How did they grow so massive so quickly? And what role did they play in shaping the very first structures after the Big Bang? We're only beginning to uncover the answers, but one thing is becoming clear. Black holes are not merely endpoints, they are organizers. They shape the flow of matter, the rhythm of star formation, and the long-term fate of galaxies. And in the quiet centers of the cosmos, they continue to influence the universe, not through destruction, but through balance, in ways we are only just beginning to understand.